Okay, period 4, period 5, period 6, algebra 2. This is me trying to basically take your Friday. I'm going to try to take your Friday and I'm going to try to flip your Friday lesson. I'm going to teach it right now. You're going to listen on Thursday night and hopefully this is going to make sense to you. And you'll come in Friday and we can do the worksheet really quick, and not really quick, but just do it right away and not waste time. The I can statements, they're all right here. I'm not going to read them to you. You read them on your own, but this is what we're going to be doing in this lesson. This lesson is about writing equations of lines. Okay, let's get started. Here we go. From the previous lesson, 2.3, we learned about slope-intercept. Slope-intercept is really nice because in slope-intercept form, we can graph a line extremely quick just by knowing the slope M and the y-intercept B. Now we did this probably on Thursday, so this should be familiar to you. Okay, now what's coming up next is right here. We're moving on to what they call, well, there's other ways to write your equation. This way would be point-slope form. Now this point-slope form actually came from the slope formula. What they did with the slope formula is they took it, and now this is something you don't really need to know, so if you want to speed me up and not listen, fine. But what they did was they took this equation, they multiplied this equation, sorry about that, they multiplied this equation, I'm not sure why that's happening. Okay, sorry, it's already messing me up. Well, that's not working. Let's go straight over here. This point-slope form is generated from this formula. Okay, you'll have to trust me on that. My eraser is popping up for some reason. Okay, now this formula is pretty simple. You just put your slope right in for M. Now to use the point-slope formula, you need to know a point and the slope. And the slope, whatever it is on your line, you drop it right there. You put it right in for M. The point, that would go here. The y value would go here, and the x value would go here. So the equation in point-slope form would read like this. Y minus y1 equals m times x minus x1. And right here it says m is the slope, x1, y1, any point on the line. Okay? The slope formula is something, it's just a tool that you'll need to find the slope. And once you know the slope, then you put it into point-slope form. All right, in point-slope form, this is a really simple form. You'll see in just a second. When it's in this form is used to go back to this form. You might be asking me, why would I go back to a slope-intercept form? Because you can graph it so easily. Okay, let's get started. The first one is going to be, hang on one second here, I can't see my scroll bar. There we go. There's my scroll bar. Okay. Now, this one says a line passes through a point, -1, 3, with a slope of -2/3. That doesn't look very good, okay? -2/3. All right. Now, what is the equation of the line? First, it says put it in point-slope form. Once you get it in point-slope form, then put it in slope-intercept form, right there. Okay, so if you're going to do that, you might want to, maybe copy the formula down. Point-slope looks like this. Now remember, this is what you should be writing down in your notes. There. Now, drop everything in and see what happens. Here we go. The slope is -2/3. So we put that in for M. X, it says x, minus x1. Well, this is x1. This is the x value in the 1 point we have. So x minus -1. And then this is the y value. It gets dropped right there. Y minus 3. Okay. Now this is actually, I'm sorry, this is my answer. This is my answer in point slope form right there. That's where you put it. Okay. Next, let's go with slope-intercept form. So the goal is always to put it back in slope-intercept form so we can eventually graph it. Okay, to put it in slope-intercept form, we solve for the letter y, just like we did in yesterday's assignment. So here I would run this through, distribute it through. So you get negative 2/3 x, and you'll get, now remember, minus 1 makes positive 1. So this is really just x plus 1. Okay. Negative 2/3 times x is negative 2/3 x. Negative 2/3 times 1 is negative 2/3. And over here you have y minus 3. All right. For us to continue, we need to solve for y. So let's add the 3 on this side and this side. Okay. And the 3's are out, and you end up with y equals negative 2/3 x. And then, of course, 3 take away 2/3 would be 2 1/3. So 2 1/3, I would write it like this: 7/3. Okay. Now, if you don't like my 7/3, and by the way, that would go in this box. That's the answer. If you don't like the 7/3, you could say 2 1/3. There. If you like that answer better, go with that answer. If you like decimals, 2 1/3 is really 2.33. Repeating. Okay? So you can do that too. All right. Now that would be putting an equation in point slope form right here, and putting an equation in slope-intercept form right here. So there's two ways to do it. This is the best way for graphing. I'm not asking you to graph, so don't worry about it, but that is why you want it in slope-intercept form. Okay, next page. All right, the next page, it says write an equation. Wow, okay. A line passes through a point 5, 1 and a point 7, 9. So you're given 2 points. What is an equation of a line in point slope form? So again, they want it in point slope form. Then they say, oh yeah, and again, put it in slope intercept form. Well, this is where you start. We always start with point slope form. So if you start here, you need a point and a slope, and we have 2 points. Well, with 2 points, you just come over here, and if with 2 points, you can find the slope, and you can find the slope pretty easy. It'd be y2 minus y1. 9 minus 1. Oh, I'm doing this again. 9 minus 1. There we go, got it. And 7 minus 5. Okay, that gives me what? 8 over 2 or 4. Slope is 4. Okay, so with the slope 4, I'm going to put it in point slope form. And remember, the slope goes in front of x minus x1. Over here, it's y minus y1. Well, which point should I put in? It doesn't matter. If I were you, I'd pick the smaller numbers and the numbers that are positive. Since they're both positive, I'd go with 5, 1. So again, x value here, 5, y value here, 1. And there it is. That is the answer in point slope form. But point slope form does you really no good, and especially when you're graphing. You have an equation, you want it in the simplest form. The simplest form is slope-intercept form. So to get it in that form, solve for y. So 4x minus 20 on the right side. Y minus 1 on the left side. Oops, that's an equal sign. Add 1, add 1. And when you add 1, these ones are out. And you end up with y equals 4x and negative 20 plus 1 it would be negative 19. And there is your equation of a line going through the 2 points 5, 1 and 7, 9. And that is pretty much the two types of forms we have. We have slope-intercept form and we have point-slope form. Okay, then we move on and we have another form. Yay, that'd be 3 forms. Okay, another form of the equation of a line is called, and this is where you need to put a little word in here, and I think I can move that box. I just can't get my, no, it's not moving. Okay, fine, it's not moving. I'll just put the word right here. The other form is called standard. So another form of the equation of a line is standard form, in which the sum of the x and y terms are set equal to a constant. Now a constant is just a number like 2, 4, 6, 8. When possible, you write the coefficients of x and y and the constant term as, and I can't move this right now, as what? Integers. There you go. So those are the two boxes. Put the names in, standard form and integers. Okay, so standard form is right here. It would look like this: ax plus by equals c. And then it says where a, b, c are real numbers, okay, and a and b are not both 0. If a was 0, this term ax would disappear. If b was 0, by would disappear, so you can't have zeros for a and b. Okay, so what's an example of this? How about something like this? 2x plus 3y equals your constant, like 5. That would be an example of standard form. An example would be, you got the x term and the y term on the left side. You've got the constant on the right side. You've got integer coefficients. 2 is an integer. 3 is an integer. 4 is an integer. What you don't want are fractions and decimals. No fractions, no decimals in front of x, in front of y, or on the right side. Okay? That's kind of a pain, but that's just the way it is. Okay, let me move over here. Let me come down and down again and extend the page. Okay, so here we go. Now, what is an equation of a line? Oh boy, this doesn't show up very well. Y equals, I think that is 2/5. Is that 2/5? 2/5 x minus 3. I'll rewrite that. 2/5 x minus 3. So in standard form, that's our goal. Put it in standard form and integer coefficients. Okay, so what you can do right away, if you don't like your fractions, I just get rid of my fractions, and what I'd see down on the bottom of my fraction is I see a 5. To get rid of the denominator, simply take your equation, multiply it by 5, 5. You pick the denominator and you just multiply both sides by 5. 5 times y, 5y. Here, 5 times 2/5. Well, the 5 will cancel with this 5 right here. I'm not going to cancel it out, not yet. So this 5 and the 5 on the bottom cancel out. So all you have left is 2x. Now the 5 is still there. Now 5 times negative 3 is negative 15. Okay? This looks good. You got integer 5, you got integer 2, you got integer negative 15. All I would do if I were you is I would leave the constant term negative 15 on this side, and I would get the x term on the other side. To get the x term across the equal sign, how do you get rid of 2x? You subtract 2x. And then you come over here and you subtract 2x. Now remember, the 5y is positive. So really what it is negative 2x plus 5y equals 2x is out, negative 15. Okay? There is another version of the answer, and the other version would be what if I would have left the 2x here on the right side, move this over, and move the 15 over. I'm not going to show all my work on that, but really all it amounts to is the 15 would have been positive, and the x term is 2x, and the 5y becomes minus 5y. So really, when you convert things to standard form, there's two versions. But notice the versions. Look at the 15. 15, look at the other 15, negative 15. Look at the 2x, and now it's negative over here. 5y is positive here, 5y is negative here. So as long as your terms are all opposite, and your constants are opposite, you've done it right. Problem 4. This one, I believe, it says y, I can hardly read it, 9.1 x minus 3.6. Okay, so we're going to take this and put it in standard form using integers. Okay, this one you don't like decimals. The other one was fractions, this one's decimals. Okay, to get rid of decimals, it's so simple. Multiply, multiply, and when you multiply, you pick a number that moves the decimal as far as you want to move it. If I move it one place to the right and one place to the right, to do that, all you have to do is multiply by multiples of 10. So if I'm only going one place to the right, it's just 10. If I would have wanted to move it 2 to the right, it's 100. 3 to the right, it's 1,000. But I only want to move it 1. So 10 times y, 10y. 9.1 times x is 91x. Negative 3.6 times 10 is negative 36. The decimals are now gone. I'm trying to find my cursor again. There we go. All right. Okay. Now, I would just bring this 91x over. I'd leave the negative 36 here. I would just subtract 91x. I would subtract 91x. Remember, 10 is positive. So basically, this is the answer, followed by 10y. All right, that is your answer. Or, remember, what if you would have put negative 36 on the other side and all the x and y terms on the right side? Then it would be 36, 91x, and negative 10y. Again, I'm not showing my work on that. You just have to either trust me or move it yourself and see that it does work. Okay, page 2, I think that's 2, is done. Page 3. On page 3, they just they give you all the forms. Okay, here's one form, slope-intercept. This is really good for graphing. Point-slope form is a good way to start. Anytime you start a problem, you probably start right here. Then convert to this, or convert to standard. Now standard form, usually standard form, it's not really a great form, but it does have its benefits. We can graph right out of this, which we will be doing in just a second. So there's the 3 forms. This form is super easy to graph. I like this form. This one, there's a simple way to graph it. I will show you right now. Okay, so this is a nice one to graph too. I'll show you. Okay, here we go. It says this. You can graph an equation in standard form. You can graph it if it's in standard form quickly by determining the x and y intercepts and then drawing the line through them. An x-intercept, I said that wrong. An intercept of a line is a point where the line crosses the axis. So here's your line right there. It crosses the x-axis here. It crosses the y-axis here and keeps going. Okay, well, wherever it crossed, that was an intercept. This one's called the x-intercept. This one's called the y-intercept. Okay? The y-intercept, right here. The y-intercept of a non-vertical line is the point at which the line crosses the y-axis. Okay, that would be, this is the y-intercept. Another thing about the y-intercept, you're always looking for the y value. You want to know where it crossed the y-axis. The nice thing about that is you always know the x value is 0. Always. When it comes to the x-intercept, that would be this one. That means you're going to look for the x-intercept. You always know the y value is 0. And that helps you to graph all this, okay? All right. Give me a second. I'm trying to find my cursor again. Here we go. I got it. And down. Our job is going to be to graph, okay? We are going to graph this equation. 3x, I'm doing this all over again. 3x minus 2/3 y equals -12. Okay. All right. So let's go get the x-intercept, which basically, to me, if you want to know where it crosses the x-axis, you're looking for x. One thing you know for sure, everywhere on the x-axis, the y value is 0. So just let 0 go in for y. And that's all you do to find the x-intercept. So let's do it. 3x minus 2/3 times 0 equals -12. And 0 times anything wipes it out. This is just gone, gone. All you have left is 3x equals -12. Divide by 3. Divide by 3 and you get -4. So the x-intercept is going to be, here comes -4, 0. Okay, let's do the y-intercept. And the y-intercept will be, you're looking for y, let x be 0. Okay, that's this. So that'd be 3 times 0 times minus 2/3. Okay, y equals -12. This is gone. All right, to solve this kind of equation, again, you don't like your denominator, 3, so let's just get rid of the 3. I wonder if I can do this. Can I just, there's my eraser. I'm going to erase this piece because it's gone. Okay, so how do I get rid of -2/3? Well, I just multiply by 3 and 3. 3 goes out with 3. That's gone. -2y equals -36. Divide by 2, -2 and -2. Y equals 18. So what's the y-intercept? 0, 18. Okay. Well, x-intercept -4, y-intercept 0, 18. I think on the x-intercept you can get away with going by 1s. So 1, 2, 3, 4. -4 is here. On the y-axis you might want to go by 2. So let me know you're doing that. And just go up 2, 4, 6, 8, 10, 12, 14, 16, 18 is about here. And there's the line. Okay, so that is the x-y-intercept method. You can use this method anytime it's in what form? Anytime it's in standard form, go ahead and use the x-y-intercept method. Now, just so you know, you always can do this. You can always, on a test or quiz, solve for y, put it in slope-intercept form, and then just graph it. It's actually really simple just to solve for y and graph it. But this is also, I think, a very simple method. Okay? All right, next up is, I think, your last page. Yes. Okay. This is just a quick little, a little story problem about, it's kind of throwing slope and graphing all in one. So let's just read it. The office manager of a small office ordered 140 packs of printer paper. So basically 140 packs of paper, printer paper he has. Based on the average daily use, she knows that the paper will last about 80 days. So 80 days from now, the paper, the printing paper, is all gone. Okay? Now, it says, what graph represents this situation? What graph represents the situation? It says to complete the table, so let's do that first. It says 0 days are going by and packs of printer paper used. How many, if we've used up 0 days, how many packs of printer paper, I guess, have been used after 0 days? Well, we haven't used any. So 0 days go by, we have not used any paper. Okay, here it says 140 packs of printer paper have been used. So if you've used all of them up, when did that happen? Well, remember, it says here, she knows that the paper will last about 80 days. Oh. So 80 days from now, 80 days, 140 packs of printer paper is gone, is used up. So if I do a quick graph the situation. At 0 days, remember X stood for days, and this stood for packs. I'll just say packs of printer paper. So 0 days go by, 0 packs gone. 80 days go by, 140, that's probably right in this area right here. Okay, so if I graph the situation, there is the line segment that would represent this, okay? Kind of a off-the-wall problem, okay? Okay, going back, trying to get to my scroll bar. Okay, and these are the last two concepts of this lesson. You got parallel lines and you got perpendicular lines. Okay, they give you a big spiel here about what's a parallel line and what's a perpendicular line. So I want you just to kind of, notice a couple things. First of all, parallel lines, I think we probably all know this, but parallel lines will not touch. They go off in the same direction and they have the same rate. They're going up and over at the same rate, which would tell me, or you, that the slopes are the same. This is the slope right here from the first line. This is the slope from the second line. I think that's obvious that the slopes are the same. All right, the y-intercepts, it says right here, the y-intercepts are not equal. Well, if they're not, that says not equal, just so you know. Look at your own notes. And that has to be true, because if they're parallel, then they're going to be separated, and if they're separated, the y-intercepts here are different. Okay? So if I said this line crossed at -2 and this line crosses at 5, an example of these equations could be this line could be, let's just say y equals 3x minus 2. 3 because why? This line goes up, so we know it's positive. So I'm going to call it 3 for a slope. What would this line have to be then? Y equals, and because this line has a slope of 3, this other line would have a slope of 3. The slope, the y-intercept, 5. So notice parallel lines basically have two things that happen. The slope is exactly the same. That's one. And the other thing I just want you to notice is, yes, the y-intercepts will be different. They just will. Okay? When you jump over here, to the other side, perpendicular lines, really what I want you to notice is one line is going up, so you know the slope is positive, and the other line is going down, so you know the slope is negative. So really, when you look at this little saying right here, right there, when they say M1 and M2, the slope of both lines, it says are negative. Negative just means opposite. So really, this word just means opposite. And if you look after the word negative, it says reciprocals of each other. So really, these two equations have to have slopes that are opposite, one positive, one negative, and reciprocals. So an example of this line, this blue line, could be y equals, and since it's going down, let's call it negative 1/2 x, and the y-intercept looks like about 2. So I'll put plus 2. Okay. Now the other line, the red line, it would be y equals, now look at the slope. It's negative 1/2 here. What's it going to be in that one? Well, it says negative reciprocal. I said don't say negative reciprocal. Say what? Opposite reciprocal. Okay? And here, if you do the opposite, you're positive. The reciprocal of 1/2 is 2x. Now, what's the y-intercept? I don't know, and you don't know, so let's just make it up. Negative 4. So then it would be minus 4. There you go. That is just an example of what the perpendicular equations might look like. The only thing you care about is right here. You care about the slope. Are they opposite? Positive, negative? Yes. Are they reciprocals? 2 over 1, 1 over 2. Yes, we did it. I'm just giving you some examples. You can read all this if you want. This is important stuff, but honestly, this is what you need to know. Opposite slopes. The slopes on perpendicular lines will be opposite reciprocals. Sorry, that's pretty sloppy. Okay, here we go. We're almost done. What is the equation? Because we got to write an equation of each line in slope-intercept form. So they want your line in slope-intercept form. All right. It says the line parallel to this equation, okay, through the point 4, 2. Okay. Now, here's the deal. This sometimes is really difficult for students, so I want you to kind of draw yourself a quick picture. This might be kind of weird, but let's just try it. Okay, since they said write the equation of each line in slope-intercept form, your line is going to be parallel to this line right here. So if I were you, I'd go like this. There. Draw two parallel lines. Okay. Put this equation right next to this one. 4x plus 2y equals 7. Okay. So this is your line. Your line is parallel to this line. So your line, you should know the slope of it. It is the same slope as this line over here. Now you can't see where I'm pointing, but all I mean is this line right here. 4x plus 2y equals 7. So what you need to do is get the slope off of this line. To get the slope, I would solve for y. Move this over here. 2y equals, and how do you move it over? Minus 4x. Minus 4x. So you're going to get 7 minus 4x. Divide by 2. Y equals 7 over 2 minus 4x over 2. And you end up with this. 7/2, that's the y-intercept. Here comes the slope right here. So the slope is negative 2, which would mean your slope is negative 2. Now, somewhere on your line, I don't know where, there's a point. It says right here, you're at 4, negative 2. Oh, okay. So if you know a point, 4, negative 2, and the slope, negative 2, then you can write the equation. They want slope-intercept form? Well, we can't go that quick. We have to use point-slope form. So y minus, here's y, Put the y right there. Y minus negative 2 equals. The slope is, what's the slope again? It is negative 2. X minus, where's the x value? Oh, it's way over here. Okay, it is 4. So you want to take this equation and put it in slope-intercept form. So run the negative 2 through and you'll get this. And then the minus minus makes a plus. Okay, solve for y. And when you solve for y, you will subtract the 2, knock it out, subtract the 2 and get this plus this. There it is. You just wrote the equation of a line right there parallel to this other line. And what you did was you stole the slope from this line. You stole it, put it on your line right here. And then you used your slope, your point, to write the equation. Very, very complex problem, but very doable. All right. Whew. Lots of talk. All right, this time, write the equation of a line perpendicular to this line right here. Y equals 2/3 x minus 1, going through the point 0, 6. You know, again, it's perpendicular. Well, just go like this. Draw 2 perpendicular lines. And you already know the slope from this line right here is 2/3. So this has to be the slope of the line that goes up. Right? So the line that goes down, the perpendicular line, and by the way, perpendicular means you have right angles. And you will say opposite, negative, and you will flip it 3/2. So there's your slope. You also know this. 0, 6 is on your line somewhere. Oh, 0, 6, okay. There's 0, 6. See, this one's your line. This is your line. And you steal the slope off of the other line. Well, no, I said that wrong. You don't steal it. You change it to its opposite, negative, and you flip 2/3 to 3/2. Okay, so here we go. Now we write the equation. I would just say this. Y minus x minus, put your slope right here in front of x minus whatever, and stick the numbers in. I've got 0 for x. I've got 6 for y. So it's y minus 6 equals negative 3/2 x. Remember, this times this is nothing, so don't even write anything. Okay, almost done. Hang on, I got to click this again. Okay, so now you move the 6 over here by adding 6, So you end up with y equals negative 3/2 x plus 6. Okay, now this is the answer to your line. Your line being right here. That's your line. That is the end of the lesson. You can always rewind it and listen to whatever you want to listen to. Hopefully it made sense. We'll try. I'll get your opinion on Friday to see where you're at. Your notes should be filled out when you get to class. All right, and that is it. We're going to wrap it up there.